Okay, good afternoon, ladies and gents. Today we're going to be looking at energy. So just to start off with, there's a little starter on the board for you there. If you want to have a go, just pause the video and see if you can work out what those words mean. Okay, moving on now. So those different types of energy there, we've got thermal energy, which is heat, we've got chemical energy, and we've got gravitational potential energy. And today what I want you to be able to do is to look at different stores of energy and where they occur. And you're going to do three things today. I want you to list different energy stores. I want you to describe about some transfers of energy, how those stores of energy can be transferred into something else, and describe the principle of energy conservation. Okay, you're going to learn the law of conservation of energy. So, just start with that. Let's look at some energy stores. So energy stores are energy that can be kept in a location, trapped to be used usefully for something else. So as an example here is an elastic band. If I stretch that elastic band now has the potential to be used. If I let go of that, that elastic potential energy will be transferred into something else and off it goes. I've got moving energy, which is kinetic energy. Think about a gyroscope. If that is spinning, that carries quite a lot of energy with it. Thermal energy. So thermal energy is heat. So hot objects have lots of thermal energy, cool objects have far less. Gravitational energy. If I have a ball here, if I lift that up against gravity, that's stored energy. If I let go of that, that's going to move. So that gravitational potential energy will be transferred into kinetic energy. And finally, I've got chemical energy. Chemical energy can be in things like cells. So this is a cell, not a battery. Inside there is chemical energy, and that has the potential to be turned into electric energy where we need it to. I've also got a candle here, so there's lots of chemical potential energy trapped there in those chemical bonds, and there's also chemical energy in this lighter. And I can transfer that energy into a flame, which is transferring it into thermal energy and light energy. And I can do the same for this candle here. If I light it, then you can see that the the chemical potential energy is being transferred into thermal energy, which is heat, but also into light energy. So, those are different forms of energy stores. There are others as well. You've got nuclear energy, that's the energy trapped in the nucleus of an atom. And if you break open that atom, lots of energy is released that way. That's how nuclear energy works. But the main sources that we deal with day to day are chemical potential energy, and particularly gravitational potential energy, and also elastic potential energy. There's a spring inside there, and if I press that, that's got the potential to be used. I'll pop it back here, fingers crossed, we might see it go in a minute, and if it does go, that's going to turn into kinetic energy. So, there's some things for you to fill in the blanks there. Again, if you pause it and have a look, see if you can work out the words, and off goes the ball. Okay, hopefully you've had a chance to finish that then. So, when objects are lifted, the amount of gravitational energy increases, or gravitational potential energy. If we slow a car down, its kinetic energy goes down, its moving energy decreases. Where does that moving energy go to? Well, it's slowed down by the brakes get hot, so it's transferred from kinetic energy to thermal energy. When we burn some fuel, the thermal energy increases and the chemical energy decreases. When we drop an object, its gravitational energy goes down as it gets faster, and because it gets faster, its kinetic energy increases. Stretching a spring increases its elastic energy, its trapped energy. And that goes the same for compressing a spring as well. If you push a spring, that also compresses it. That will increase its elastic potential energy. So, there's 4 examples there. What are the energy transfers taking place? Now, I can find the ball that I've just fired across the room. Bear with me. There we go, that was rolled under the sofa there. Okay, so here's the ball. This has got gravitational potential energy. If I let go of it, what's going to happen? It's going to fall. So its gravitational potential energy store will decrease and its kinetic energy will increase as it goes down. Okay, an elastic band being fired. We saw that earlier on. So the elastic band being stretched, that's got elastic potential energy stored in it. When you let go of that, the elastic potential energy stored decreases and the kinetic energy increases. A candle burning, we go from chemical energy, and that decreases as the thermal energy and the light energy increase. And finally, a ball thrown upwards, as you throw it, that's got kinetic energy which decreases as it slows down, and that increases its gravitational potential energy. Once it reaches the top, it runs out of kinetic energy, then the gravitational potential will be converted back into kinetic energy as it falls downwards again. Okay, so hopefully you've managed to list different energy stores. You've also been able to give some examples of different energy transfers there. And finally, we're going to look at something called the principle of energy conservation. This is the law of conservation of energy, and it's one of the fundamental laws of thermodynamics. The universe needs this law to work. And what the law says is energy can never be created or destroyed, only moved around from one store to another. Energy is never created nor destroyed, just moved from one form to the other. What that means is there's a set amount of energy in the universe that doesn't change. So energy I put into a system has to come out of it at the end. If I lift this up, I put a certain amount of gravitational potential energy into that. If I let go of it, all of that energy will have to be transferred into something else. 100% of that energy will be transferred. Not necessarily to what I want. In the case of the candle, there's light and heat. I might not want both of those energies, but all of the energy will be transferred. So here's some examples. When a ball is dropped, its kinetic energy goes up by 10 joules. How much does its gravitational energy go down by? Now, if you want to pause that and have a think about that, because of the law of conservation of energy, what that says is that if its kinetic energy goes up by 10 joules, its gravitational potential energy must have gone down by 10 joules. When a candle burns, 125 joules leaves the chemical store. By how much does the thermal energy store increase by? Again, pause it and have a think for a second. Okay, can we have a look at that again? Quickly remind ourselves. There's my little candle. So 125 joules is leaving the chemical store. How much does the thermal energy store increase by? Well, the answer should be 125 joules, but actually it won't be. And the reason for that is because some of that energy will be transferred as heat. I can feel the heat on my hand above that. But some of that energy is coming off as light. You can see the light coming off that, and that's another form of energy, light energy. So the answer should be 125 joules. It probably isn't. Probably about 120 joules, maybe, will be coming out as heat. About 5 joules will be coming out as light. So, when a car is moving, both the kinetic and thermal stores increase and the chemical energy in the fuel goes down. So if the chemical goes down by 100 joules and the thermal increases by 40 joules, how much does the kinetic energy store increase by? Okay, so thinking about that in terms of maths, I've got 100 joules of chemical energy on one side, and I should have 100 joules of energy on the other side. If 40 joules of that is thermal, then the other 60 joules must be kinetic energy. Now, in reality, that's probably not the right answer, because some of the sound of a car, some of the energy of the car, will be coming off as sound energy, and you'll be able to hear a car going past. So the answer should be 60 joules, but it's probably slightly less than that. Okay, so what have we covered? We've listed different forms of energy. So we've got thermal, we've got kinetic, we've got gravitational potential, we've got elastic potential energy, we've got nuclear energy, we've got chemical energy. All of those different energy stores. We've looked at different energy transfers, and hopefully you can describe the principle of energy conservation by looking at how much one changes in one direction. That means the other must increase by the same amount. So if you go on to GCSE Pod, you will find there are 15 questions on there. You have a go at those 15 questions and submit those, and we'll see how you do. If you have any questions or any problems with the work, feel free to contact me at my email, which is crumb@tahs.net. Otherwise, good luck.